In this video, we present heart rate scaling for exercise video games. The mechanism allows players' in-game performance to be based on their effort relative to their fitness level. Exercise video games combine entertainment and physical movement in an effort to encourage people to be more physically active. Multiplayer exercise games take advantage of the motivating aspects of group activity by allowing people to exercise together. However, people of significantly different fitness levels can have a hard time playing together, as large differences in performance can be demotivating. Our goal is to narrow the performance difference between players with different fitness levels. To help address this goal, we have created the Heartburn game. In Heartburn, a player races a truck along a twisting track. If a player strays off the track, her truck slows down. A stationary bicycle and wireless gamepad are connected to a computer running the game. Players control their avatar by pedaling the bike and steering with the gamepad. In the standard version of the game, a player's cycling determines the truck's speed. Heartburn is a multiplayer exercise game allowing two players to race. The first player to reach the end of the track is declared the winner. Our approach in narrowing the performance difference between players of different fitness levels is to base players' performance on their effort relative to their fitness level, rather than their raw power. We use heart rate as an indication of players' physical effort. However, heart rate on its own is an imperfect measure of effort. Here we see the first 71 seconds of an example game of Heartburn. The green line shows a player's standard game speed as a function of pedal cadence and gear, reported in game units of kilometers per hour. The orange line shows a player's heart rate. This example illustrates that there is a lag between performing exercise and heart rate increasing. Similarly, when a player's effort is reduced, there is a lag before heart rate decreases. This lag also varies from person to person, depending on fitness levels. Based on the properties of heart rate during exercise, we derive three principles to be applied when using heart rate as an input mechanism for exercise video games: base performance relative to target heart rate, scale speed logarithmically, and apply a nimbleness factor to make controls feel more natural during changes in pedal speed. To experiment with heart rate control in exercise video games, we created a second version of the Heartburn game using our scaled heart rate control mechanism. In the scaled version of the game, players wear a polar heart rate monitor. The data collected by the monitor is received by the stationary bicycle and sent to the computer running the Heartburn game. Our scaling mechanism is then applied to determine a player's in-game speed. Here we see in-game speeds for the first 71 seconds of a standard Heartburn race between a 29-year-old male, shown in blue, and a 66-year-old female, shown in red. It is apparent from the speeds of the two players that the younger player is able to pedal faster and therefore is at an advantage. By applying our heart rate scaling mechanism to the Heartburn game, we can see that the gap in speed between the two players is greatly reduced. In a study of 24 participants, we found that heart rate scaling was effective in cases where participants were significantly mismatched, but reduced competitiveness when participants were closely matched. Participants were equally engaged by both standard and heart rate scaled versions of the Heartburn game, indicating that heart rate scaling feels sufficiently natural. Overall, our results suggest that heart rate-based scaling mechanisms should be considered by designers of exercise video games as a way of supporting competition among people of varying fitness levels.